Okay, now what we're going to do is actually run a one-way ANOVA. I want you to open up database teachers 2 this time rather than teachers edited so that we perfectly match the outputs of which you have a copy. In this particular case, what I want you to do is refer to output 9, how to run the ANOVA, and then the specific output that comes from the way we're going to run it. So I'm going to go back to my model here, our little flow chart. And I'm going to read question 9. It says, is there an overall mean difference in collegiality between teachers in different school types, specifically magnets, non-magnets, and schools within schools? So the first thing that you should hone in on is there a mean difference. That tells me I'm in causal comparative again, which tells me where to go in SPSS to run the test. You should then ask yourself, how many dependent variables do I have? You have 1 in this case. It's collegiality. Collegiality is a measure of the extent to which teachers work well together. So the items might say something like, our teachers work well as a team. I regularly share ideas with my colleagues. I often talk with other teachers about how to best serve students. And you average all those means and you get a variable called collegiality. Then you say, how many groups do I have? And that variable is type, and it has 3 groups. It has 3 different types of schools, specifically magnet schools, non-magnets, and schools within schools. Magnet schools are schools to which no one attends based on where they live. They have to apply to go to the school. So it might be something like a performing arts school or a special science academy. Non-magnets, just think of them as neighborhood schools. You go to that school because you live in a certain attendance zone. Schools within the schools are sort of a blend within the two. Half of the kids in the school go there because they live in the neighborhood, and another percentage go there because they participate in a special program at that school. So the key here is I've got 3 groups. That's going to tell me a couple of things. If I have 3 groups, they're independent. You can't go to more than one of those types of schools at the same time. I could run 3 independent samples t-tests. I could say, is there a difference between collegiality in magnets and non-magnet schools? Is there a difference in collegiality in magnets and schools within schools? And is there a difference in collegiality between non-magnets and schools within schools? The reason, again, I don't want to do that is because to run those 3 tests, I'm tripling the amount of mistakes, inaccurate interpretations that I want to make. Again, I have an error rate of 0.05, and I don't want to repeat that 3 times when I can have an overall error rate comparing the 3 schools at once. So I'm in causal comparative, so let's run the test. I go up to analyze, I go down to compare means, and I see one-way ANOVA on the bottom of the list. My dependent variable is near the bottom. It's called collegiality, so I put that in my dependent list, and then I find my factor, which is called type. Not Q type, but school type. And I drag it over, and typically I wouldn't click OK yet, but I'm going to show you this analysis in stages. So let's just click OK. And all that I got, because I didn't ask for anything specifically, was the test that says, is there a difference between teachers' reports of their levels of collegiality in those 3 types of schools? My F statistic of 0.572 is associated with a significance level of 0.564. There is no difference. So I would stop there. There's no differences in teachers' reports of collegiality between teachers that work in magnets, non-magnets, and schools within schools. F equals 0.572, P equals 0.564, Again, that's greater than 0.05, so no significant difference. That's where I would end here, but I should have run more outputs when I click on an ANOVA. So let's just go back to the ANOVA, compare means, one way, and we have those variables in there. I would want to add some things that are not part of the fall. Specifically, I would go to options, and the most important thing is to click on the descriptive statistics. The second thing that's appropriate to click on is the homogeneity of variance test. Remember when we ran independent sample t-test, the variance needs to be equal for the test to be valid, or you should run a different type of test. So because analysis of variance are similar to independent sample t-test, they also require the assumption of homogeneity of variance. So this is like the Levine's test that we ran for independent t-test. The next thing that I would click on is called post hoc test. And post hoc means after the fact. When you run an ANOVA between three groups, if there was a difference between the three groups, you need to know then between which of the three groups. And that's what post hoc tests do. So the post hoc tests that are by far the most common are called Bonferroni and Tukey. And you can hardly go wrong if you just clicked Bonferroni or Tukey every time. We're going to, in this case, run Tukey as our post hoc test. And I'm going to go down and I'm going to click OK and run the same analysis of variance. This time, I ask for my descriptive statistics. And so I can see 536 teachers who work in magnet schools rated their level of collegiality 3.06, non-magnets, there were 813 teachers. The mean collegiality level was 3.04. Schools within schools, 84 teachers, a mean of 2.99. That's just the descriptive statistics. The next thing I asked for was, give me that test of homogeneity of variance or equality of variance, Levine's test, if you will. And that value, p-value, was 0.882, which means I can't reject that I have equal a variance. So I can assume equality of variance, or I can assume homogeneity of variance, which is my null. And I only conclude there is inequality of variance if that significance value was less than 0.05. The next table is the only table that we saw in the last output, which is basically the test of the overall model. Is there a difference between these three means for those three groups of teachers? My F value, which was again based on the difference between the groups over the difference within each of the groups, and that significant value is 0.564, which is greater than 0.05. So there are no differences in teacher collegiality between teachers in magnet, non-magnet, and schools within schools. Because there's no difference, I wouldn't even interpret the post hoc test. You shouldn't even look at these. But again, just for the sake of understanding what a post hoc test, you just need to remember post hoc means after the fact. So what it's doing is essentially, it's almost doing three independent sample t-tests for all practical purposes. It's saying, what's the magnet collegiality level minus the non-magnet teacher collegiality, and I get a mean difference. I look at significance, 0.807, there's no difference between collegiality and those two. I then compare magnet to school within a school, so it's the magnet mean minus the school within the school mean, a value of 0.06594, significance 0.57, greater than 0.05, not significant, and then I compare non-magnet to magnet, and I don't even need to look at that because it's just the reverse of magnet minus non-magnet. So I've compared magnet to non-magnet, magnet to school within a school. The one thing I didn't do up here is non-magnet to school within a school. That mean difference, the magnet mean, non-magnet mean minus the school within a school mean is 0.046. That's associated with a significance value of 0.74, so there are no differences. But again, because my overall test of the whole ANOVA model is 0.5604, not significant, I wouldn't actually even look at these outputs.